The question says a metal tube of length 30 centimeter and weight 0.45 newton is fitted with a wooden handle 10 centimeter long and weight 0.30 newtons. The question demands us to calculate the distance of center of gravity from the middle of the end. Now, before start calculating, it's the first thing we need to understand. This is a classic center of gravity problem in physics, where we combine two objects of different lengths and weights and then determine where the balance point lies. Now, what is center of gravity? Center of gravity is the point where the entire weight of the system can be considered to act. Now, from the question, we have the metal tube of length 30 centimeter, which have the weight of 0.45 newtons. But again, we have the wooden handle, which is fitted to the middle foot of length 10 centimeter and weight of 0.30 newtons. What is your task? Our task, we need to find the position of center of gravity relative to the middle of the end. Now, what does it mean? This means we need to treat the handle's middle points as our reference point and calculate how far the combined center of gravity rise from it. Now, to understand this, you need to picture a tool made of two parts, a long metal tube and a shorter wooden handle. Each part has its own length and weight. Now, if you hold this tool by the middle of the handle, where exactly will it balance? In other words, where is its center of gravity? Yes, so now we need to draw the diagram to present the whole scenario of the questions, and keep in mind that we have a metal tube and we have a wooden handle. Wooden handle was attached to the metal tube. So I'm going to start with the diagram of the metal tube, and this it is the diagram, just a sketch of the metal tube, which I've got 30 centimeter length, but again the question says the weight of this the weight of the metal tube is 0.45 newtons, and I'm going to locate this weight at the center of the metal tube. Why? Because I'm just assuming that the metal tube is uniform, and if it's uniform, its weight is considered to be acting at the center. So here it is the weight of this metal tube. But the question says that this metal tube was attached with the wooden end. So the wooden handle of 10 centimeter in length. So this is the wooden handle, and the weight of the wooden handle is 0.3 newton. So the same applies here. The wooden handle is uniform, therefore its weight is acting at its center. So let me write it this way. C1 is the center of the wooden handle, and C2 is the center of the wooden handle. So now, another task here, we need to indicate the location of the center of gravity of the body when metal tube and the wooden handle are joined together. So the center of this body is going to be in between C1 and C2. So here is a, but we don't know exactly at what distance from C1 and C2 is. We just know that the center will be located at the distance between C1 and C2. So I'm going to write here C. So again, we need to apply here the principle of moment, which says the sum of clockwise moment is equal to the sum of clockwise moments for the body to be in rotational balance. So where are we going to take our moment? So let us take the moment from C. So I'm going to write here taking moments about C. So C is our reference point. C is the point of rotation of this body. So again, as the principle of moment says, the sum of clockwise moment equal to the sum of anti-clockwise moment. So Now, we need to indicate some distance here to smooth our calculation. So I'm going to write here 15 centimeter. Why 15 centimeter? We all know that if C1 is the center of the metal tube, therefore, and the metal tube has got the length of 30 centimeter. So from here to here, it's going to be 15 centimeter. The same goes to this, the distance of C2 from the end of the wooden handle, which is going to be 5 centimeter. Now, the distance between 0.45 and 0.3 Newton is 20. But our task here, we need to calculate the center of gravity from the wooden from the wooden end, from the center of the wooden handle. Therefore, I'm going to lie here as x. Now, if this is x and the distance from 0.45 to 0.3 Newton is 20, therefore here it's going to be 20 minus x centimeter. So we have x centimeter, which is the distance from the composite mass of the composite body to the mass of wooden handle. So from there now, it's possible now to calculate, since we have all the distance and all the forces required in the equations. So now we can calculate. We can do some math here to obtain the remainder of the questions. So what I'm going to do here, I'm going to identify which among these two 0.45 and 0.3 Newton would cause the body to rotate clockwise and anti-clockwise. Now, since we are going to take moment from C, therefore we have to take this one to cause the body to move clockwise, while this one will cause the body to move anti-clockwise. So therefore, what I'm going to have here, 0.3 times x and 0.45 times 20 minus x. So what I'm going to have here, 0.3x equal to 9.0 minus 0.45x. Therefore, 0.45 will come to this side. So we are going to have 0.75x, and here we are going to left with 9.0. 9.0, so I'm going to divide both sides by 0.75 to obtain x 0.075. Therefore, what I'm going to have here, x equal to 12 centimeters. So in fact, x is equal to 12 centimeters. Now, let us refer to the demand of the question. The demand of the question says we have to calculate the distance of center of gravity from the center of the wooden handle, and x is the distance from the C2, which is the center of the wooden handle, to C, which is the center of gravity of the whole body. So this is our answer. So the distance of the center of gravity from the middle of the wooden handle is 12 centimeter. Thank you. And this is how we have to apply the principle of moment to calculate the distance of center of gravity from the wooden handle.